Hi, everybody. It's great having you here online with you. And the talk today is given by Matthias Egger, who is an emeritus professor of epidemiology and public health at the Institute of Social and Preventive Medicine at the University of Bern. And his research has focused on methodological issues in clinical epidemiology and public health research, notably evidence synthesis and meta-analysis, infectious diseases, and socioeconomic health inequalities. But he has also served as a president of the Research Council of the Swiss National Science Foundation from 2017 through 2024, emphasizing evaluation equality and quality, transparency, open access, gender equality, and research integrity. And we are very happy that he's here with us today. And I won't keep you any longer. So Matthias, feel free to start.
Okay, thanks very much, Paul, for this kind introduction. I'm really going to talk about research on research at the Swiss National Science Foundation, but I'm not going to talk as a representative of the Swiss National Science Foundation. I'm going to look back at the time I spent there as the president of the Research Council. So this is not an official SNSF talk, but it's a talk by someone who's been there for several years and has done, as you'll see, or helped perhaps make the SNSF more evidence-based. We'll discuss that later on. So let me share my slides. So as we all know, the Swiss National Science Foundation is really the main funding body in Switzerland. And these are some figures for the year 24. So almost 3,000 grants were funded that year. The success rate was about 33%. I hate to say that this is probably going to go down because the budget is going to be cut and the SNSF is getting always more and more proposals. The budget is above 1 billion and there are about 80 plus evaluation panels. And the whole spirit of the SNSF is really a fantastic organization by science for science. And the graph shows you the distribution of the funding. Project funding is the most important funding element. And then their careers, their programs like the NCCRs or the national research programs. And you see that across the sort of three main disciplines, about 40% goes to biology and medicine, about a third to maths and natural and engineering sciences, and about a quarter to the humanities and social sciences. Now, what is the role of funders in the context of reproducibility? This is, after all, the ReproducibiliTea. And of course, you all know this article by Marcus Munafo and colleagues, which sort of discusses the role of different actors in our shared quest to make science more reproducible. And of course, you remember that this is about the methods, about reporting and dissemination, about making the results reproducible, the evaluation, and also about providing incentives. And in this article, Munafo and colleagues really argue that funding agencies have a role to play in virtually all of these areas. I could now take you through one by one, but I'm going to show you an overall slide, what has been happening at the SNSF in recent years. That's this one here. And I'm going to focus on a few elements with, of course, a focus on research as the title of my talk says. So in terms of evaluation, the SNSF has introduced a new CV format, which probably some of you may have seen. It's a narrative CV, and you see it made news in Nature, Swiss funder unveils new CV format to make grant evaluation fairer. We also introduced a new evaluation procedure, the so-called UEP, or Unified Evaluation Procedures, with a modified lottery. And I'm going to talk about this in a few minutes. We developed large language models in order to analyze peer review reports and to understand, obviously, peer review is a very central element in the evaluation of the proposals that any funding agency receives. But to analyze them, you need a large language model. We also train the chairs and panel members, etc. In terms of open science, we're the members of Coalition S. We introduce data management plans, and we, of course, support you. We support the Swiss Reproducibility Network. And in terms of research on research, over that sort of 8-year period I was at the SNSF, initially we spent quite a bit of time on predatory publishing, because there was a lot of concern that the open access movement, if you like, which we of course supported, is being abused by some journals and publishers that do not really comply with, accepted standards of editorial practice, etc. Then I think the focus moved a bit to peer review, to impact, and of course we have the career tracker cohorts. So we track, I shouldn't say we, it's the SNSF, but it's one of the studies that we initiated during my time. So we prospectively follow up those people who got career funding, who got, for example, an Ambizione or an SNSF professorial grant, etc. Perhaps the most important thing is that we try to influence research culture, and we developed a model of excellence, and also at the organization we revised the statutes, and I think this revision with better division of responsibilities, a strengthened academic leadership, etc., also strengthened research culture or culture at the SNSF. So the next slide just shows a few outputs that we produced on predatory publishing. We were interested in who reviews for these journals. We were interested in the definition of predatory journals, and we discovered that this is very difficult, and there's a real gray zone between legitimate and predatory journals. And we also discovered that these blacklists or white lists or positive lists and negative lists, perhaps better, are not very useful. One important development that the SNSF reacted to was this explosion of special issues, particularly by MDPI, a publisher based where you are in Basel, and Frontiers, a publisher based in Lausanne, which is a approach to basically attract more papers. You invite people to edit a special issue, and then of course you attract all the article processing charges. And the SNSF has decided not to fund these special issue articles anymore, because it was felt, also based on the article that you see on this screen or on this slide, which I really recommend. It's a fantastic piece on analyzing, the problems of scientific publishing and the strain on publishing, which these special issues, of course, increase a lot. So another really important topic is bias in peer review. And this lovely study, an experimental study, this is about journal peer review, where these authors basically sent the same paper, once with a Nobel Prize winning scientist as the author, and once with a little known junior scientist as the author, to different journals. And what happened? The acceptance rate differed massively depending on who the author was. So it was, let me see, over 20% recommended accept when the Nobel laureate was shown as the author of the same paper, but less than 2% did so when the research associate was shown. This is a lovely study which sort of illustrates the limitations of peer review and the fact that the peer review is a human activity and it's influenced by implicit or explicit biases that relate to the seniority of the person submitting the proposal, the gender, the institution, etc. So we also looked at that at the SNSF, and we looked at in project funding at almost 40,000 peer review reports that related to about 11,000 proposals. And we analyzed this on this slide by the applicant's gender and the reviewer's gender. And we looked at the overall score. So what do we see here? Let me see whether I can get the can you see my cursor? Yeah, okay. So basically what you see is that female reviewers, these two results here, they tend to be less positive than male reviewers. Okay, so their scores tend to be lower than the male ones, both for male applicants and for female applicants. But what we also see is that male applicants tend to give quite a bit higher scores to male reviewers tend to give quite a bit of higher scores to male applicants up here compared to female applicants. This difference is much less for female applicants. So the gender of the reviewer and the applicant influence what the overall score is. Now, the overall score, of course, is only one element of a peer review report. There's a lot more in peer review if you analyze the text, the actual content of the peer review. And we did that first in collaboration with Publons, using 10,000 peer review reports stratified by impact factor of the journal. The impact factor of the journal, although we all tried to get rid of it, continues to be, I would say, something people watch and take into account when choosing journals. And one argument often is, even if they don't take my paper, I get good reviews. I get good peer reviews. And in this study, we developed a language model to analyze the content of the peer review reports that people received from these journals. And we saw indeed that the higher impact journals were slightly more detailed, particularly when it came to the methodology. They assessed the methodology slightly more in depth, but as the conclusion that you see on this abstract says, differences were modest and variability high indicating that the journal impact factor is a bad predictor of the quality of peer review of a manuscript. So we sort of, I would say, with this study, to some extent, showed people that using the impact factor as a criterion to choose your journal to get good peer reviews probably mostly doesn't work. And we then extended this work to grant peer review reports that we receive at the SNSF. And of course, we receive many of these every year. You saw the study on 40,000. And this one this paper is basically detailing the methodology, the supervised machine learning approach to assess these peer review reports. But I'm now going to show you also a few results which are not published yet. We're working on that paper, the sort of epidemiology of the peer review, the grant peer review report. Of course, in general, grant peer review is hidden. There has been more and more data on journal peer review because journal peer review gets more and more open, often published alongside with the paper, whereas grant peer review is still very hidden. And that's why I think funding agencies really should make an effort to analyze these data because no one else can do it. They are not, for legal reasons, often not in the public domain. So the next slide shows the impact of research domain and of the gender of applicant and reviewer, a bit similar to what we saw a few minutes ago, on the length of the peer review report. Of course, that's a very simple thing to look at. You can just count the words. And you see that in the social sciences and humanities, SSH, peer review reports tend to be considerably longer than, for example, in the life sciences, LS, or in mathematics, in informatics, natural sciences, technology, MINT. And you see mathematics has the shortest peer review reports, more like 500 and something words, whereas art and design is at 1,100. Now, this may be entirely appropriate. It also reflects, I think, disciplinary cultures and practices. Nevertheless, I think it is interesting. What is also interesting is that female reviewers, and that's part B on this slide, tend to get longer reviews than male reviewers. Why would that be? And also, female reviewers write longer reviews than male reviewers. So female applicants get longer, independently of the gender of the reviewer, and female reviewers write longer reviews. Interesting. Let's discuss later. Now, this is showing positive and negative on the left, positive statements, on the right, negative statements, again, across these I think it's 22 disciplines, from mathematics to epidemiology and preventive medicine, which is my field. And if we start with epidemiology and preventive medicine, then you see we are very critical in our discipline. The peer review reports include a lot of negative statements and relatively few positive statements compared to mathematics, where basically most statements are positive and there are far fewer negative statements. So again, interesting disciplinary differences depending on which discipline you look at, and probably something you should be aware of if you work at a funding agency. Now let me go on to the new CV format, which I already mentioned a few minutes ago. basically that format in some ways is quite similar to the standard CV. It includes a section on education and training, previous and current employment. But then, rather than have a long list of publications, the applicants are asked to list their major achievements, their major contributions with a few selected works. And these can be publications, but it could also be a piece of art. If we're talking about the section on art studies. And also, we are no longer looking at chronological age, but academic age. So how many years have you spent in research or in academia, rather than how old are you? And most importantly, absolutely no metrics. No impact factors, no age indices, nothing is systematically assessed in this new CV format. Now the question is, how has that influenced peer review? And we're now looking at that using our large language model in the same data set that I showed you before, with the length of the reviews by gender of applicant and reviewer and by discipline. So if we look over time, how many reviews mention metrics? And this is the variable applicant quantity. This is essentially metrics. You see that before the introduction in spring 22, about 40% of the reviews mentioned some metrics, the age index or an impact factor of a journal, or even cumulative impact, any such metric. And the introduction of the narrative CV really changed that. You see that this has gone down to below 20%, and it's now really approaching 0%, which is what we would like to see, which is quite amazing. Now, let me come back to the modified lottery, which I mentioned at the beginning. Now, one of my experiences that I will never forget as a member of the Research Council, before I became president, I was a member of the Research Council in Division 3, so in biomedicine, was the so-called Ausscheidungssitzung. So that was the meeting when really the decisions were taken which proposals will get funded. And this was a very interesting meeting in the sense that it was a bit of a, as you see on the slide, a bit of a fight. You know, members of the Research Council tried to get their candidates funded, or, you know, there was really it was quite an interesting meeting, a very lively meeting, but also I felt somewhat problematic meeting, because depending on, you know, what the character of the member of the Research Council was, how dominant these people were or less dominant, etc., people got funded or not. So we introduced a so-called unified evaluation procedure, again in 22, the UEP, and you sort of see the flow of the evaluation process from submission to the communication of the results. And what I would like to highlight here is the Bayesian ranking and the random selection for comparable votes. So the random selection among the group of applications where you have to say they're probably of similar quality. We can't fund all of them. Let's do a random selection and fund those who are lucky. Okay? And I'm going to illustrate that. So when you do a little experiment and you basically create two panels, you could do that ideally at random. So you, for example, you have 20 experts in astrophysics and you divide them into 10 and 10 randomly. And then you send them the same proposals, okay, to evaluate. What do you think the concordance between these two panels will be? How many of the proposals will be rated as fund or not fund? How similar will these outcomes be? And you can calculate the agreement in this 2x2 table. Now, you see the agreement on the table is around 70%, which illustrates there is an element of chance in the evaluation, also in the evaluation of peer review at the journal, but here, these are all funding agencies. There is an element of chance. The same panel, randomly divided, the two panels will not be 100% concordant. And of course, where they disagree is typically the middle ground. These are good proposals. They're not excellent. They're not poor. They're good proposals. They're potentially fundable, but there's disagreement which one should be funded. And that's basically what this discussion was all about at the final meeting. So in this situation, it is probably a good idea to acknowledge that there is an element of chance. And that's what we did, developing a Bayesian ranking and lottery approach, which we tested using data from the Swiss National Science Foundation. And the first thing I want to show you is that panel members are not created equal. Panel members, independent of the proposal, tend to be more positive or more negative. They're humans. And some of them just have a tendency to be more generous, if you like, or more positive, and others have a tendency to be more negative. And that is a characteristic of the panel member and not of the proposal. And you see these are actual data from the SNSF, which if you are interested, you could read this article where this is described in great detail. So this is one issue. The Bayesian model takes this into account because not always all panel members are present. Some have a conflict of interest. Some may have family duties and are absent, or they're not well, so they don't attend the panel meeting. And the Bayesian model corrects for that in the sense it knows, oh, someone who tends to be positive is missing, and it corrects for that. More importantly, it ranks the proposals and acknowledges chance. So what you see here is, for example, for the humanities, you see that these proposals from 1 to 11, 4 of them are ranked very high. So they're close to 1, the best, and the second is shared, third, the fourth rank. And you see the credibility intervals, you see the uncertainty which is attached to that rank. Now, in this case, the funding line is the dotted line. It is not a problem. You clearly can identify 4, these are research fellowships, by the way, junior research fellowships. You can identify 4 that are clearly fundable, and then the rest up here is not going to be funded. They are above or below the funding line, depending on how you look at it. Now, medicine, if you go to medicine, you see that you have, again, in this case, 5 yellow ones, which are clearly fundable. They are the first 5 ranks. And then you see 4 in purple. And these 4 are basically of very similar quality. You know, previously, probably we would have said this one is better than that one. But that is not the case if you look at it scientifically. These two are not distinguishable. They cannot be distinguished. They sit on the funding line. If we can still fund one or two of these in this group, let's choose that lucky person at random. That is the modified lottery, which acknowledges that in the middle group, you can have violent discussions, but much better to acknowledge that these are all good proposals. Unfortunately, we cannot fund all of them, so let's choose one at random. So this is the modified lottery that we introduced, and interestingly, which has really, I think, been quite popular. People actually liked it. The panel members liked it, perhaps because they could go home earlier, because they could avoid these long discussions about the middle group. So that has really worked quite well. And other funding agencies have done that before us. Others are considering it. So it's sort of a topical issue in research funding. And of course, there are a lot of open questions around this modified lottery. Does it really reduce bias? Does it increase transparency? Does it reduce conservatism? And so on. And there's clearly a need for more research. And of course, one of the exciting things is that with the modified lottery, the SNSF now has a randomized trial of funding, because some people got it, some didn't, at random. So in that middle group, funding was randomly allocated. And of course, you can now do a study where you examine what the funding does to these people, to what extent these people are doing better in their academic career, and so forth. So you can basically assess the effect of research funding on their career and also on the outputs, etc. Until now, we've done that using regression discontinuity designs, where basically you look at a threshold, which is the funding line, and those just below and those above are almost, random, and you can analyze these two groups. But it's, of course, much better to do it fully random, like in the modified lottery. We've also done simulation studies, and I already mentioned the career tracker cohorts. So the Swiss National Science Foundation, by law, has to fund excellent research. You see, this is the English translation of the Federal Act on the Promotion of Research and Innovation, the RePA, and it explicitly mentions excellent research. But what is an excellent research project? The SNSF has never defined what excellence means. But recently, or a few years ago, it introduced a model of excellence, realizing that excellence is a multi-dimensional concept, and it has something also to do with research culture. So you see on this slide, and you can look at it at the on the website of the SNSF, it's about the question, needs to be original, relevant, the methods, rigorous, of course, open, ethical, the behaviors, and that's where the culture comes in, perhaps more than for the other two, collaborative, engaging, acknowledging. So a good research culture is sort of situated around values and ethics, integrity, openness, transparency, but also interpersonal norms, if you like, collegiality, collaboration, inclusivity, respect, mentorship, and so forth. So the SNSF acknowledges that the research culture is an important element. Now, I've been sort of advertising now for a few minutes what the SNSF has done, but I would like to end by saying the SNSF could do more. And I want to show you a few examples of what other funding agencies do. For example, the Netherlands Organization for Scientific Research, which is the sort of equivalent to the SNSF in the Netherlands, had a call on replication studies to address the replication crisis. Spot on, you know, here is money to do important replication studies. The Cancer Research UK, a major cancer funder, has partnered with important journals in order to promote registered reports. Again, in the Netherlands, Open Science NL, together with the NWO, just had a call on research on open science. And finally, the foundation in the US on Huntington disease has, and that's perhaps the most radical step, has created a repository for protocols reviewed by this charity funder. And upon study completion, the protocols will be made publicly available so that the research findings can be judged in the light of the planned proposal, which again is a fantastic initiative, I think. I've been sort of trying to move in that direction at the SNSF, but that's difficult. I think the SNSF is still as a national funder. This is a private one, the Huntington Disease Foundation. The SNSF cannot do everything other funders can do. So with that, I'm going to finish and stop sharing. And I'm really looking forward to your comments and questions.